And under the questions that I like to classify as in terms of, okay? So it's questions like this where they say cos of 20 degrees equals P, determine the following in terms of P. Generally, they say without the use of a calculator, and they say with the aid of a diagram. Okay, so I'm going to show you guys how to figure out how to draw, in which quadrant you draw in the diagram and things like that. Now this one here isn't so complicated. It says cos of 20 degrees. Please do not type in cos of 20 degrees in your calculator. We don't need that, okay? So I'm going to take a picture of this, but everything that I've written here, I've written it out in steps. So if you don't want to watch the video and you think you can follow all of my steps, you are more than welcome to do that. They want cos 160, 40, sine 20, and sine 140. And we know that we can change all of these in terms of 20 degrees by using our reduction formulas that I spoke about quite a few times already in the previous video. Anyway, let's go to drawing the diagram. Because it's an acute angle below 90 degrees, we know it's in the first quadrant, which is what I did. 20 degrees over there. I have P, right? P is over 1, so I put it over there. And we know that because it's cos, it's the same thing as x over r. So see, I took my P as my x value, my 1 is my r value, and now I need to figure out what my y is, which is what I've written down over here using Pythagoras, because this is a 90-degree angle. Using Pythagoras, I get this. Now we know that it's both positive and negative for our y when we square root something, but in the first quadrant, y is positive. Let's make a note of that over there. Right? If it was negative, it would have been maybe the side here in the third and fourth quadrants. Then you would have used the negative part. Don't forget that for the radius or the hypotenuse, the r is, that value is never ever going to be a negative one, right? Okay, let's continue. So the next thing that you need to do is take each of those questions individually and simplify them, which is what I'm doing. Reduction formula, second quadrant. In the second quadrant, it's 180 minus. There we go. And if it's 180 minus in the second quadrant, when I'm working with cos, it's negative. That's what I've got over there, right? And we just need to put the negative. We have cos of 20 degrees. We already know, without even using the diagram, cos of 20 degrees was P. So that's why I filled in P. All right, and that's what I wrote there. Step 4, write it out in terms of P. This one is still simple. Okay, I have cos of 40 degrees. See how my cos of 40 degrees can be written as cos 2 times 20 degrees. Grade 12 stuff, double angle identity, right? You can pick and choose whichever one of the 3 identities for cos of a double angle. I picked this one over here because it's working still with the cos, right? But we don't have to really go back to the diagram yet. Okay, I opened it up to this using the identity. This here is squared of that 20 degrees, so therefore it's just P squared, and I simplified it like that. All right, the third one that we have is sine of 20 degrees, and this is where the diagram comes in. Okay, for sine, we know it's a y value over the r value. We figured out our y value as root 1 minus p squared. There it is. It's supposed to be over 1, but I don't need to write the 1. Okay, that's why I had it just like that, and that is our answer. Okay, last one, sine of 140 degrees. This here is an acute angle. It's going to be in the second quadrant. In the second quadrant, it's 180 minus, and sine is positive. So 180 minus 40 degrees, and there we go, it's sine positive. As you can see again, this is a double angle. Why? How do I know that? Because my original one was 20 degrees, and here I have 40 degrees. So double angle, and then we open up the double angle identity and just fill in sine of 20 degrees. Figure it out from there. Cos of 20 degrees is P, and that is our answer. At this step, if there's anything else that you can simplify, you simplify, otherwise you leave it as is. Okay, let's pause so we can do another example. Alright, something slightly more complex in the way that it's written, okay? Let's unpack this or look at it. So I have 3 sine A equals negative 1. Alright, and they've given me a restriction for this particular angle. It has to be between 90 degrees and 270 degrees, both included. Okay, and then they've given me tan of another angle. B is 3/4, and they've given me again a restriction of B where it should be between 90 and 360. It says determine without the use of a calculator the value of, and they've given us two particular expressions that we need to find the value of. Remember, it says without the use of a calculator, meaning you are not going to press shift T and figure out what angle B is and figure out what angle A is. No, they don't want that. So how do we do that? We draw in diagrams. How do we figure out in which quadrant we work in? I simplified this first one over here as this, and then I asked myself, because I can see it's negative, where is sine negative? So filled it in on a small diagram. Sine is negative in quadrant 3 and quadrant 4, right? Then I went back to my restriction. It has to be between 90 degrees and 270. Where's 90 and 270? This quadrant, this quadrant. Where are they both the conditions met? In quadrant 3. Hence why I drew my diagram in quadrant 3. I filled in the information. This here is the same thing as, let's just fill it in on this side, y over r. So my y value is -1, my r value is 3. Remember, I just said that the r value is never ever the negative one. It's the x or the y that's the negative, right? I figured this out using theorem of Pythagoras. You can write it down and show that. There's sometimes a mark for it. Please show it down. Otherwise, for the purpose of explanations, I just calculated it and put it there for you, okay? I did the same thing with the T and B one. Here it is over here. Where is the, you can see it's positive. Where is T and positive? Quadrant 1, quadrant 3. Right, I put the dots. Then my restriction between 90 and 360. 90 and 360 gives us this one, this one, this one. We are both conditions met. Quadrant 3. Filled in all the information onto my diagram. I knew this here was a Pythagorean triplet. Pythagorean, this is unrelated really to this. It's more related to theorem of Pythagoras when we investigated with you guys in grade 8. Yes. Theorem of Pythagoras, when we did that, you get certain numbers that people just know. They call Pythagorean triplets, okay? 3, 4, 5 are one of them. Another one is what is this? 3, 6, and 10. That's another Pythagorean triplet. Okay, unrelated to this here. But anyway, let's continue. I have the expression that was given to me, cos A minus B. There it is. I can see this is a compound angle, and using my compound angle identity, I've opened it up like this, right? Cos A, all I needed to do was figure out I need the x value over the r value. So my x value over my r value. That's exactly what I did. For cos B, I need my x value over my r value, but for the second diagram. So -4/5. There we go. Sine A, we know it already. And sine B, I need my y over r, so -3/5. There we go. And then I know it says without the use of a calculator, but you can actually use the calculator to work this part out and this part out. Although this one wasn't so complicated, we just had to multiply 2 times the 4 to give us the 8 root 2, and the side negative and negative gives us a positive. 1 times 3 is 3. Okay, there's nothing really that can be simplified over there, so that's our answer. Okay, the second one, it says cos 2a minus cos 2b. Both of them double angles. So I open them up using double angle identities. You can choose whichever one you want to. This is the ones that I chose to use. And same like how I did over here by just substituting. That's exactly what I did. For cos A, do you see how I put the squared because it said squared? Same thing over here. You just then simplifying. Don't forget, because it says without the use of a calculator, you need to show a few more steps in between with your simplification, and that's the answer. If you chose to use any of the other identities, you would come to the exact same answer. Okay, that's all that you need to know about in terms of questions.